everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters part 2. So here we are going to find a dash and b dash using formulae. So let's get going. Problem solve y double dash plus y equal to cosecant x cot x or d square y by dx square plus y equal to cosecant x cot x using variation of parameters. In the previous video, we have seen this same problem and by finding y, y dash and y double dash, but here we are going to find a dash and b dash using some formulae. Okay, let's get going. So here we are given a differential equation of order 2. Given differential equation, y double dash plus y equal to cosecant x into cot x. We know that y double dash or y2 is equals to derivative of, second derivative of y with respect to x, right? Now we can replace y double dash with d square y by dx square plus y equal to cosecant x cot x. Consider the given equation as equation number 1. Now we can write d square y by dx square as capital D square y, right? We'll just replace it with differential operator form plus y equal to cosecant x cot x. Then d square plus 1 into y equal to cosecant x cot x. Just we'll take y common from these two terms, then we'll get d square plus 1 into y. Consider it as equation 2, which is in operator form. Say f of d into y equal to some function of x, okay, where f of d is d square plus 1 and r of x is cosecant x cot x, right? And the homogeneous equation of 2 is d square plus 1 into y equal to 0. Consider it as equation number 3. Let's now find the solution of this equation using the auxiliary equation, and later we'll find the general solution of equation 2 or equation 1 using the solution of equation 3. Okay, let's see that. The auxiliary equation is f of m equal to 0, where f of m equal to, we are having f of d, which is d square plus 1. Let's replace differential operator with m, so that we'll get f of m equal to m square plus 1. Now the auxiliary equation becomes m square plus 1 equals to 0, then m square equal to minus 1, then m equal to plus or minus square root of minus 1. Since square root of minus 1 is I, so we'll replace square root of minus 1 with I. Okay, therefore m equal to plus or minus I. The roots are complex conjugate. We know that when m equal to a plus or minus ib, the solution of homogeneous equation will be e power ax into c3 some constant, okay, into cos bx plus c4 into sin bx. Why I am using c3 and c4 here is I wanted to appear c1 and c2 in the final general solution, so I am using c3 and c4 here, okay, for a time being. Now when a equals to 0, we'll get e power 0 into x, which is e power 0 into c3 cos bx plus c4 sin bx. Since we know that e power 0 equals to 1, so let's replace e power 0 by 1. We'll get 1 into c3 cos bx plus c4 sin bx which is equals to C3 cos bx plus C4 sin bx, right? Now the solution of homogeneous equation becomes the solution of the homogeneous equation equation 3 is y equal to, just compare plus or minus I with plus or minus ib, then for b equal to 1 we'll get cos 1 into x plus c4 sine of 1 into x. This becomes y equal to c3 cos x plus c4 sin x, solution of homogeneous equation or equation number 3. Now let y equal to, just replace these parameters or constants with functions of x, a and b, then we'll get y equal to a cos x plus b sin x, or just we'll just replace c3 and c4 by a and b here. Here a and b are functions of x. Be the general solution of equation 1 or 2, where a and b are functions of x. Now just compare this, the solution with C3u plus C4v, or compare the solution with y equal to au plus bv. We'll get u and v, right? Where u is cos x and v is sin x. Also, u is cos x and v is sin x. Okay. Now we need to find a and b. Here we will find a and b using formula a dash equals to minus v into r of x by uv1 minus vu1, and we'll find b dash using u into r of x by uv1 minus vu1, right? We are having u and v, and r of x is cosecant x cot x. Now we need to find uv1 minus vu1 because it exists in both the formulae. Okay, so firstly let's begin with uv1 minus vu1. Here v1 is nothing but derivative of v with respect to x, and u1 is nothing but derivative of u with respect to x, right? This is equals to u is cos x into v dash derivative of v minus v into u dash derivative of u, which is equals to cos x into derivative of sin x with respect to x is cos x minus sin x into derivative of cos x with respect to x is minus sin x. This becomes cos square x minus into minus plus sin square x, or we can write it as sin square x plus cos square x, and sin square theta plus cos square theta equal to 1. So we'll get sin square x plus cos square x equals to 1. Now we got uv1 minus vu1 value, which is 1. Let's now find a dash and b dash using this formula. We have a dash equals to minus v into r of x by uv1 minus vu1, right? Then a dash equals to minus v sin x into r of x cosecant x cot x by uv1 minus vu1 is 1, which is equals to minus sin x into cosecant x into cot x, right? Since we know that cosecant theta equals to reciprocal of sin theta, so we can replace cosecant x with reciprocal of sin x. into cot x, so that sin x gets cancelled and we'll get minus cot x. So we got a dash equals to minus cot x. And now here itself you find a, okay, or just find b dash. Okay, fine, let's find a from this a dash. We have a dash equals to minus cot x, right? We can write a dash as derivative of a with respect to x. Now let's separate the variables by taking differential dx to RHS. We'll get dA equal to minus cot x into dx. Now we can perform the integration because the variables are separable here. We'll get integral dA equal to minus integral cot x dx. Since we know that integral d theta equal to theta and integral cot theta d theta equal to log sin theta or log mod sin theta, we'll get integral dA equal to minus integral cot x dx is log sin x plus integral constant say some c1. So therefore a equal to minus log sin x plus c1. So we got a from a dash equals to minus cot x, and we got a dash from this formula, right? We got a equal to minus log sin x plus c1. Now let's find b dash using this formula. We have the formula b dash equals to u into r of x by uv1 minus v1. This is equals to u cos x into r of x cosecant x into cot x by uv1 minus v1, which is 1, is equals to cos x into cosecant x into cot x, right? So let's write cosecant x as 1 by sin x into this cot x. This is equals to cos x into 1 is cos x by sin x into cot x. This is equals to, since we know that cos theta by sin theta equal to cot theta, right? So we can replace it with cot x into cot x gives cot square x or cot x whole square, right? Therefore b dash equals to cot square x. Now let's find b using b dash equals to cot square x. We have b dash equals to cot square x. Here b dash is nothing but derivative of b with respect to x. Now take the differential dx to separate the variables. So here the variables are separable. Let's now perform integration. We'll get integral dv equal to integral cot square x dx. Since 1 plus cot square theta equal to cosecant square theta, then cot square theta equal to cosecant square theta minus 1, right? Since cot square x equal to cosecant square x minus 1, let's replace cot square x here. We'll get integral dv equal to integral of cosecant square x minus 1 into dx. This becomes integral dB equal to integral cosecant square x dx minus integral dx. Since we know that integral d theta equal to theta and integral cosecant square theta d theta equal to minus cot theta, then this becomes integral dB be equal to integral cosecant square x dx is minus cot x minus integral dx is x plus integral constant c2. Therefore, b equal to minus cot x minus x plus c2. So we got b from b dash equals to cot square x, b equal to minus cot x minus x plus c2, right? So we got a and b. Let's now write the general solution using y equal to a cos x plus b sin x. Therefore, the general solution of 1 or 2 is given by y equal to a cos x plus b sin x, then y equal to a minus log sin x plus c1 into cos x plus b minus cot x minus x plus c2 into sin x. This equals to minus cos x log sin x plus c1 cos x plus into minus minus cot x sin x minus x sin x plus c2 sin x, right? Plus into minus is minus x sin x plus c2 sin x. The above equation becomes y equal to cos x log sin x plus c1 cos x. Say from these two terms we can take minus sin x common, so we'll get minus of cot x plus x into sin x plus c2 sin x, right? From this we'll get y equal to, write the terms involving c1 and c2 firstly. We'll get c1 cos x plus c2 sin x minus cos x into log sin x minus of cot x plus x into sin x, which is the required solution. Therefore, y equal to c1 cos x plus c2 sin x minus cos x log sin x minus of cot x plus x into sin x is the required solution. This completes the problem. So we have seen part 2, the second way or the other way of finding solution, general solution of the given equation using variation of parameters. I hope you'll understand. See you in the next video. Until then, bye bye.